Here is problem 9 of the test. Once again, if you need to open up the problem in another window, feel free to pause the video and do so. This is 2002 AIME 1, number 9. In this problem, Harold, Tanya, and Ulysses, they're painting a very long picket fence. So Harold is starting with the first picket. So Harold goes from 1, or he paints the first picket. Then he paints every H picket. So the next one he paints is H plus 1, then it's 2H plus 1, and then so forth. Tanya goes from 2 to T plus 2, 2T plus 2, and so forth. While Ulysses, goes from the third one and then every youth one, so 2U plus 3, so forth. So these are the pickets that each of them paint. So now we want to see if a positive integer 100h plus 10t plus u is paintable when the triple HTU of positive integers. Okay, so we're getting that HT and U are greater than 0, and our integers results in every picket being painted exactly once. And then we want to find the sum of all the paintable integers. Okay, so first of all, this is an AIME. So AIME answer format must be less than 1000. So each paintable integer must be less than 1000. And this caps h to be less than 10. Because if h was at least 10, then the positive integer 100h plus 10t plus u would be greater than 1000. Okay. So the main thing we want to focus here is that every picket is being painted exactly once. That means first of all, that every single picket, meaning we're not really given how many pickets there are, so we can just assume there are infinity pickets, and every single one is painted by one of the three. And also that there is no overlap between people. Okay, so if every picket is painted by one of the three, what does that mean? Basically, it means that within, say, like for Harold, for example, since he paints every Hth picket, that means that every single thing within that H picket, like 2 mod H, 3 mod H, 4 mod H, for example, those must all be covered by Tanya and Ulysses. But the problem is Tanya and Ulysses are not exactly, they don't exactly behave nicely either. Because Tanya and Ulysses also skip by other amounts, T and U. So in fact, from this, we can pretty much get the notion that H, T, and U do not seem to be very big. Like, at least we know that H is less than 10, but also that T and U cannot be very large too. If T and U are very large, then that forces the other variables to be relatively smaller to try to patch in the holes, patch in the numbers that are not painted from the large gap. And that becomes pretty hard to do as one of the variables grows bigger. So we can kind of move forward with the idea that most of these H, T, and U pairs, or these triples, should be quite small. Okay. And our second condition is that there is no overlap between people. And what does this mean? It means that because Harold is covering what? Harold is covering 1 p mod h. Tanya covers 2 p mod t, and Ulysses covers 3 p mod u, or modulo. I got accustomed to saying the LaTeX format of it. Okay, ooh, and that's a semicolon there. Oops, did it again. Okay, so when do these overlap? These overlap if, for example, if Harold and Tanya overlap, that means we have a solution that is the simultaneous equivalences. X is equivalent to 1 p mod h, or modulo h, and 2 modulo t. So if this happens, then we have this. So when does this not happen? Or when does this happen so we know that which ones cannot be solutions? Well, we know that by the Chinese remainder theorem, we are guaranteed a solution if HT are relatively prime. Thus, H and T cannot be relatively prime, and also T and U cannot be, and H and U cannot be. So, HTU cannot be pairwise relatively prime, or 2 of this cannot be relatively prime. This doesn't mean that they share a common factor, it just means that that, for example, we can have I'm having trouble thinking of a pair that works. So maybe they do have a common factor. I wonder, if 2 of HT and U cannot be relatively prime, does that mean that there is a common factor that's greater than 1? Interesting question. But we're not focusing on that at the moment. So we don't really have any leads, but we know that, or we think that HT and U should be relatively small. You know, H is bounded by 10, it has to be a positive integer, so that's a good time to test out cases because we only have, 9 cases. So first, if H equals 1, then Harold, well, he's doing 1 mod 1, so Harold is painting every fence. And this leaves no room for Tanya and Ulysses, so this doesn't work. Next, if H equals 2, then Harold is painting every odd fence. And what does this mean? It means that Tanya is painting 2 mod something, so Tanya and Ulysses have to cover the even fences. Tanya probably can, because it's a 2 mod something, so as long as T is even, Tanya does not paint any odd fence. And for Ulysses, well, we know we know that T and U both have to be even, because any 2 have to be relatively prime. So because U is even, 3 mod any even number will be an odd number, I think, right? Yes. Then Ulysses can only paint odd fences. And this is a contradiction because there's overlap. That doesn't work. Okay, so if H equals 3, 3. Tanya has to paint 2 mod something, and Ulysses has to paint 3 mod something. Okay, so let's try to fill in some of the gaps. So Harold is painting, let's see, 1, 4, 7, 10, 13, 16. Okay, that should be enough. And Tanya and Ulysses have to kind of fill in the gaps, right? Tanya and Ulysses, or one of them has to paint 2, 3, 5, 6, 8, 9, 11, 12, 14, and 15, and so forth. So how can they do that? Okay. First of all, we know T and U must divide 3 because of our property. So we can just test. If T is 3, then T covers 2 mod 3. And thus the only blanks left are the 0 mod 3, which is easily satisfied. So if U is 3, and U equals 3 equals is the only U that actually satisfies this, because if the only blanks left are the ones with 0 mod 3, and if U is anything else, then it won't cover only those. So we do have a solution, is HTU is equal to 3, 3, 3. This works. Okay. So if T is anything else, let's see if T is 6. Then T covers 2 mod 6, which is basically 1 mod 3, so this doesn't work. It covers every even number in 2 mod 6, so Harold overlaps with that. Does it? No, I'm actually being rather dumb here. No, this is not true. Okay, so T covers 2 mod 6, and Harold is covering 1 mod 3. So what is left for Ulysses here? So Ulysses is left with 2 is covered, but 3 isn't. 5 is not covered, and 6 is not. And we already see a problem because these should be evenly spaced. So T equals 6 doesn't work. So does T equals anything else work? If T equals to 3 times something, then how do we know that there isn't a Ulysses that can cover that? I guess the main problem here is that, say T equals to 3k for some integer k. Then we are covering, then Tanya paints 2 mod 3k. And 2 mod 3k, the only problem with this is that it's not going to cover the other 2 mod stuff. It doesn't cover, say, 2 or 5, for example, if k is not 1. It doesn't cover 8 if k is not 1 or 2, and so forth. So basically, like I said before, if k is getting bigger, if t is getting bigger, then we're leaving a larger gap that these smaller values like h equals 3 can't fill up. Now this is relatively informal, but this is an AIME question, so we don't need too much rigor. So t equals 3 should be the only one that works. So now if h equals 4, then Harold is painting 1 mod 4. Okay. Then what else works? We need Tanya to paint every 2 mod u and Ulysses to paint every 3 mod t. Or the other way, 2 mod t and 3 mod u, right? Okay. So Harold is painting stuff like 1, 5, 9, 13, and so forth. And we are left with stuff like 2, 3, 4, 6, 7, 8, and stuff. And we see quite a big problem here because there are 3 numbers in each gap that have to be filled by 2 themes. So what can we do about this? So missing ones are 2, 3, 4, 6, 7, 8, 10, 11, 12, and so forth. Well, if you look closely, we see that it seems that all the even numbers are still here. So in fact, we could just let, for example, one of them cover the even numbers, and that will eliminate a significant portion. In fact, it will actually work, because if we eliminate all the even numbers, then what we have left are 3, 7, 11, and etc., which differ by 4. So so I realized here that making it in mods was probably not a very good idea, but in any case, we'll continue. So if we make Tanya, for example, so if t equals 2, then we cover 2, 4, 6, 8 like we wanted. And this is the only t that will actually cover all the even numbers, because Ulysses, because it's 3 mod something, can't cover this. So t equals 2 is the only one that works. For example, if we have t equals 4, then this covers only 2, 6, 10, which misses quite a few. And that leaves you like 3, 4, 7, which doesn't line up with Ulysses. Okay, so that means if t equals 2, then u must be equal to 4, because that gives you the 3 mod 4 stuff, which works. And any other t doesn't work, so we move on. Now, right now we have the solutions HTU is equal to 3, 3, 3, and 4, 2, 4. And this right now gives us a sum of what? 3, 3, 3 plus 4, 2, 4 is equal to 7, 7, 5, 7. So if there is another triple, then it must be less than 1000 minus, or rather 999 minus 757 equals to less than or equal to, actually, mind that, which is 242, which means h is less than 3. And then, but we already considered all these possibilities, so the answer is going to be 757. And of course, you could test things out for h equals 5, h equals 6, h equals 7, but then the problem becomes more theoretical, and rather you would spend just more time than necessary on this question.